If you took Mount Everest and dropped it into the Mariana Trench, its peak would still be 2 kilometers underwater. We are diving into the deepest scar on the planet's crust, a place so alien we know more about the surface of Mars than we do about what's down here. Welcome to the Mariana Trench, specifically the Challenger Deep, the deepest known point on our planet's seabed. We're talking about a depth of approximately 10,935 meters, or nearly 36,000 feet. To put that into perspective, if you took Mount Everest and dropped it into this trench, its peak would still be drowning under 2 kilometers of water. Down here, the environment is alien. The temperature hovers just above freezing, perpetual darkness reigns, and the pressure exceeds 1,000 atmospheres. That's 16,000 pounds per square inch. It is a world of crushing finality. For a human, being here unprotected would mean instant implosion. But here's the catch. Life doesn't just survive here. It thrives. Before we can meet the remarkable residents of Earth's deepest abyss, we must first comprehend the sheer hostility of their environment. We call this the Hadal Zone, a name derived from Hades, the Greek god of the underworld. It's a fitting title. Spanning from 6,000 to nearly 11,000 meters below the surface, this realm is a world of perpetual darkness and near-freezing temperatures. But its defining characteristic, the one that makes it a physical death trap for almost all life as we know it, is the unimaginable pressure. Here at sea level, the entire column of air stretching to the edge of space pushes down on us with a force we call 1 atmosphere. It's a weight we never notice because the fluids and gases inside our bodies exert an equal outward pressure, creating a perfect equilibrium. We are built for this specific balance, but venture beneath the waves, and that balance is immediately and violently disrupted. Water is nearly 800 times denser than air, and its weight adds up with terrifying speed. For every 10 meters you descend, another full atmosphere of pressure is piled on. By the time you reach the bottom of Challenger Deep, the pressure is over 1,100 times that of the surface. It's so intense it fundamentally distorts the very chemistry of life. Proteins, the intricate molecular machines that power our cells, are crushed and forced to unfold. Cell membranes, which need to be fluid, are squeezed until they solidify into the consistency of cold butter. This raises an obvious and profound question. Why would evolution push any animal to live here? Why abandon the sun-drenched, nutrient-rich surface for a frozen, crushing, and utterly black dungeon? What possible advantage could there be in a place that seems so determined to extinguish life? The answer, surprisingly, is simple: stability. The deep ocean is the most constant environment on Earth. There are no storms, no seasons, no droughts, and virtually no predators dropping in from above. If, and it is a monumental if, an organism can solve the crushing pressure problem, it gains access to an entire kingdom, a vast and uncontested sanctuary all to itself. But solving that problem isn't just a matter of being tough. It requires a complete reinvention of biology, a set of adaptations that can only be described as a biological magic trick. To understand life in the abyss, we must first redefine what life can be. Let's start with something that blurs the line between microscopic and macroscopic. Meet the xenophyophore. At first glance, you might dismiss it as a dirty sponge, a discarded piece of crumpled paper, or perhaps a strange mineral formation. But this is something far more extraordinary: a single-celled organism. A solitary cell that can grow up to 4 inches wide, forming a visible, tangible structure on the seafloor. That's simply massive. In the world we know, single cells are the invisible building blocks of life, forever hidden from the naked eye. Down here, in the crushing dark, they are giants. This simple fact challenges our most basic assumptions about biology. How can something so seemingly fragile survive the immense, bone-shattering crush of the Hadal Zone? The secret isn't strength, it's surrender. They don't fight the pressure. They simply don't have the rigid, complex internal structures that would be obliterated by thousands of pounds per square inch. Their cellular membrane is incredibly pliable, allowing the extreme pressure to equalize inside and out. Instead of building a fortress, they build a home. They meticulously construct delicate, labyrinthine shells, known as tests, out of the materials at hand: sediments, the skeletons of other microorganisms, and even their own waste. This intricate structure isn't for defense, but to create a massive surface area for nutrient absorption. Evolution didn't make them tough, it made them profoundly resourceful. Next, we meet a creature that takes a completely different approach. This is Hirundellea gigas. These are amphipods, crustaceans you might recognize as the tiny scuds in a pond. But here, they are titans of their kind, growing to the size of your hand. They are the dominant scavengers of the trench, swarming any food that falls from above. But as a crustacean, they face a deadly paradox. At these depths, the water is so saturated with carbon dioxide and under such immense pressure that it becomes corrosive. The calcium carbonate used to build shells and skeletons literally dissolves. For most shelled creatures, descending this deep is a one-way trip to oblivion. It's physically impossible to keep a conventional skeleton intact, so how do these giants keep their armor from dissolving into the water around them? The answer, discovered only recently, is nothing short of biochemical genius. Researchers found that these amphipods have evolved to secrete a layer of aluminum hydroxide gel that completely covers their bodies. Yes, aluminum. They actively extract trace metals from the seafloor mud they consume, processing it to build a chemical shield. This translucent biogel acts as a barrier, preventing the corrosive deep-sea water from ever touching their calcium carbonate shell. It's like evolution installed a custom-fitted hazmat suit. This isn't just strange biology, it's a form of natural alchemy. They are literally turning the mud of the trench, the very floor of their hostile world, into a sophisticated suit of armor. It's a powerful testament to life's ability to not just endure the impossible, but to harness it. In the deepest, most hostile corner of our planet, the Mariana Trench, we find an animal that seems to defy the very laws of biology. It's a place where the pressure is over 1,000 times greater than at the surface, a crushing force that should make complex life impossible. And yet, here it is. Meet the Mariana snailfish, a creature that shouldn't exist according to everything we know about vertebrate biology, and the deepest fish ever discovered by humankind. When we think of deep-sea monsters, our minds conjure up images of terrifying teeth and armored scales. We picture the nightmarish anglerfish or the formidable fangtooth. But the snailfish shatters that stereotype. It looks more like a raw chicken breast, somehow swimming gracefully in the eternal dark. It is small, pink, and so translucent you can almost see through it. It is completely scaleless, a stark contrast to the armored beast we imagine. Its skeleton is so pliable, its bones are barely hardened, and its skull is not even fully fused, remaining partly open. You might look at it and think it's fragile, a delicate ghost adrift in the abyss. But here's the profound twist. Its apparent fragility is the very source of its incredible strength. It's a masterclass in adaptation. Down here, rigidity is a death sentence. If you had dense bones and air-filled cavities like a surface dweller, the immense pressure would snap your skeleton and crush your body instantly. The snailfish survives because it doesn't fight the pressure, it yields to it. It is made mostly of water and gelatinous tissue, allowing it to perfectly match the density of its environment. The pressure outside is equalized by the pressure inside, making it effectively immune to the crushing force. But the real magic, the true secret to its survival, happens at a microscopic level, deep inside its cells. The extreme pressure doesn't just threaten bones, it attacks the very building blocks of life. Proteins. It forces them to misfold into useless shapes, halting vital biological functions. To counteract this, the snailfish is packed with a special molecule called trimethylamine N-oxide, or TMAO. This remarkable compound acts like a microscopic scaffolding, physically bracing the proteins and holding them in their correct, functional shape against the relentless pressure. The deeper you go, the more TMAO you need to survive. And this chemical arms race leads to a fascinating and absolute limit. Scientists have calculated that fish physically cannot live deeper than about 8 to 200 meters. Why? Because past that point, Their cells would need to be so saturated with TMAO that their internal fluid would become saltier than the surrounding seawater. This would reverse the process of osmosis, causing water to be drawn out of their cells, leading to fatal dehydration. The Mariana snailfish, found at depths of 8,178 meters, lives right on the razor's edge of the impossible. It is the undisputed monarch of the deep, thriving in a realm where no shark or other vertebrate predator can ever follow. Finally, we reach the very bottom, the sediment of Challenger Deep. Even here, where the snailfish dare not go, life persists. We find microbial mats, carpets of bacteria thriving on the seafloor. But what do they eat? There is no sunlight for photosynthesis. Instead, they rely on marine snow, the dead, decaying matter falling from the surface miles above. But they also have a secret weapon. The tectonic plates here are grinding together, exposing fresh rock to seawater. This creates a chemical reaction called serpentinization, which releases hydrogen and methane. These microbes don't eat food, they eat rock and water chemistry. They are a life form completely disconnected from the sun. It forces us to ask, if life can survive here, fueled by the heat of the earth and the chemistry of rocks, could it survive in the oceans of Europa or Enceladus? Evolution didn't make them dependent on the sun. It made them dependent on the planet itself. The Mariana Trench isn't just a deep hole in the ocean. It is a testament to the stubbornness of life. We look at the darkness, the cold, and the crushing pressure, and we see a wasteland. Nature looks at the same conditions and sees an opportunity. From the aluminum-plated armor of the amphipods to the gelatinous genius of the snailfish, these creatures prove that there are no bad environments, only different solutions. Because on this planet, the impossible isn't rare. It's just waiting to be discovered. If you want to see more of evolution's strangest mistakes and masterpieces, make sure to hit that subscribe button. Until next time, keep looking deeper.